Okay, welcome to the second part of the tutorial on organizing your car as an F1 in Schools car, bringing it into QuickcamPro where the milling files will be cut. So you open up QuickcamPro and this is what you see, and click on 3D model and you'll be asked to find an STL file with the 3D model. Now I'm going to bring in this one that I just made before. Click open and there's your car. Now you can use the mouse to move it around if you but I'll show you which way. We want to orientate it in a certain way, and either way, leave your car as it is. Notice that we've got this section down here which is a set of axes, three-dimensional axes. They are X, Y and Z axes, and we'll talk much more about those in a minute. Notice, look over here as well, that your model down the bottom right hand here should indicate that the three dimensions 223, 50. If it's 36 hundredths out, don't worry about it, but if it said 52 or 53, you could be in problems. 65, so they're the dimensions of our block, which is what we wanted. If they're not correct, you have to go back and fix up your STL file by going back into Inventor and finding out what the problem is. Why is your car oversized or undersized? So far the billet, don't be concerned about that. Let's just move on to the next. And when I click next, this object appears. And if I click it around, you'll see it. It's a purple arrow. That is the replication of the machining tool which we are using to machine the file. But that's not set in the right orientation for us. We have to move the car around because we're not machining from the back of the car, we're going to machine from the side. Now over here where it says orientate model, by clicking on the up arrow and down arrow you'll move your model around. We want to go to the y-axis, flip it around so that the car is facing towards your right. So the left of your car is where the gas canister goes in, the right hand side is where the car is heading as if it was on the racetrack. And we're going to machine from that side. It has to be that way because that's how the spigot goes in to support the car on the left, and the gripping arm supports the car on the right. So the car must be orientated like that. Right, when that's set, you'll notice that Y is now 270 degrees, Z is 0 and X is 0. That's fine. Go to next again. And what's the we're now going to set the depth of cut, because remember the milling cutter can't cut all the way through the block. It can really only cut to a certain depth. Now the block is 65 deep, half of 65 is 32.5. We're going to allow 2 more millimeters and make it minus 35.5 as the Z cut depth. What that means is that from the top here all the way down we're going to go beyond halfway as the limit of our cut. And the reason for that is that the tip of the cutter is rounded, it's got a ball nose, has a radius of 3, 32.5 plus an extra 3 millimeters to get rid of that rounded section makes it 35.5. So change that to minus 35.5 as your Z cut for all your cars, and then click next. Now we've got to set the billet size. Now the billet size, the X dimension, so if you stand there with your arms poked out and looking straight ahead, the X movement of the axis is from your left hand to your right hand. That's the X movement. Your arms are pointing in that direction. The Y movement is backwards and forwards, so it's the back of your head towards the front of your nose. So if you went to walk forward, you'd be going in the Y direction in that plane. And the Z is from your toe to your head. That's the up and down. So if we're going to mill from the side, we want the face to be the Y face. I beg your pardon. We want the X face to be 223 because that's the length of the block. We want the Z face to be 35.5. Well, it's not actually, it's going to be 65. That's how deep we want the cut to be. And the Y face is going to be 50. That'll be the height. So the car's being machined on the side over here. Alright, and the blue indicates the Z axis. That's the length 223. And the depth is going to be 65. So reproduce those dimensions. Next. Now if I move this car again, we can see that it's been put into a machining plane and it should look something like that. we're now going to, the scale should always read 100%, so make sure that is the case. If the scale is not 100%, you've got a problem with the block, your size of your block. Go back into Inventor and fix it up and export it as an STL. It must be 100% or 99.9 or 99.3 or something very close to 100%. Don't click Fit to Billet, just make sure that's 100%. Okay, that's all good. Model dimensions look fine. We're going to change click Next. Set model position. Actually, we're going to go back a little bit something here and do something. We're going to extend the Y dimension. See the Y dimension there? We're going to extend that by, no we're not, we're going to keep it as 50. Keep it as it is, go to Next. The model position is automatically set for you. You don't need to be concerned about it. It's already been zeroed. That's a jig and a fixture which is set up purpose-built for this particular project. So don't be concerned about that. Just click Next again. Now set model boundary. Where it says extend model boundary here, extend the Y model boundary by 3 millimeters. 1, 2, 3. Why is that? Well, when the milling cutter passes around, remember it has that rounded edge and it's a 6 millimeter diameter. We want the milling cutter to be able to move all the way past halfway as it's cutting, past halfway through past its center of axis, so that it will actually produce a clean edge. So we've got to extend the model boundary out a little bit by 3 millimeters. So go up to 3. Next, make sure that you've got a ball nose cutter selected over here, 6 millimeter ball nose cutter. It says 1/4 inch, 6.35, don't stress over it. If it does say that, 6.35, you can click on this, edit it, and then make sure over here that you can specify the diameter as being 6 millimeters on the dialog box. See, that's what the ball nose cutter looks like. And if you had a flat cutter, you'd indicate it. Ours is going to be ball nosed. All right, we'll click OK. Now, proceed on. The next stage is to set up a machining plan, and that is what path will the tool take as it moves over this to cut out your object. So let's click Add a Machining Plan, and you've got a whole bunch of different sorts of plans. For a simple basic startup, we don't want to take too much time, choose a Raster Finishing plan, which basically is across, moves along a line and then moves diagonally across to create the next line. So click Raster Finishing. Dialog box pops up here. Change the step over, which is the distance the milling cutter moves every time it takes another cut, to 0.8 from 0.9. Make sure the feed rate's 4500, that's fine. Spindle speed's 23,000. All that's correct. The height. Make sure raster angle here, make sure that is 270 degrees. Make sure. If it's not, change to so it is. Next thing you know, go to Machining Boundaries and click Custom. And you'll notice that now you've got this grayed out area. So the entire block is selected as a machining boundary. We don't need the machine to move backwards and forwards over the block. It's a waste of time, and you spend enough time doing this. So we're going to reduce the X. Remember, the X is all the way along this side here. Y is backwards and Y is backwards and forwards, and Z is up and down. So we're going to reduce the X, the maximum of the X boundary to, we're going to drop it down a little bit. So see, as I'm clicking this down, we're going to 215, 216. You see the machining boundary moving in. Now I know the car's 175. Let's make it 176 millimeters, and there it is. So the machining boundary, I might extend it a little bit further than that, 177, and I've saved myself a whole lot of time. The tool doesn't have to pass over that blank area now, and it'll just machine. Now I could specify the other end and you may want to do this if you're machining the bottom of a car. You don't want to waste all that time. You could reduce the other end of the x-axis, the minimum dimension, make it lesser or greater and so forth, and bring it in as I'm doing now. Can you see it on the left hand side coming in over here? Look, as it's turning out, I want it to machine all the way to the end, so I'm going to click 0. I'm okay with that. I click OK. Alright, and wait a little bit. Now you can see the contours of the machining. So they are the actual machine tool paths as it's going to go around. That's what it's going to create, how it's going to machine. And it'll stop just about over here, where I'm indicating with the mouse cursor on my right. Okay, all of that's good. So click Next again. Now this is the fun part. You can simulate what's going to happen. Drop the speed down to slow, and you can click play, and you can watch the simulation as the machining cutter cuts 1/2 of your project. I'll play it one more time. There it goes. You notice how it has to work its way. It's got that ball nose, can't get it, and it doesn't create the full hole inside the axle, just puts a dimple there. So click next again, and now we have to click the datum position. Now this is a bit tricky. The X, Y, Z position. Remember I told you in the previous video that the datum position relates to the reference point, which must be located in the center of the gas canister housing. But because we pulled our car around, it wasn't in the right position when we imported it. We're going to have to play around with this. Now in the X position, the datum should be at 0, which means from side to side the datum position should be exactly at the 0 point. And it is. There it is. You can line it up. I can see it. It's at the 0 point on the side and side angle. On the Y axis, which is the backwards and forwards towards us, it has to be 32.5, but it's got to be negative 32.5. No, it doesn't. It's going to be 32.5. I want to get it right in the middle of that gas. It's the Z, the Y position, no, the Y position, I beg your pardon, is going to be, we want it to be, I happen to know it's 29 millimeters up from the base. So let's make it 29. And the Z position is 32.5 in. No, negative 32.5. There we go. Alright, so I've told it, let's have a look here. Yeah, that looks exactly right. Okay, so what I've told it to do is that the datum position from the front face of the block, it is the Z position is negative 32, which is inwards, 32.5, which is half of 65. I've told it that the Y position is 29 millimeters, so from the base of the block up is 29 millimeters, which I know is the exact location of that hole, that canister hole. And the Z position is at a 0 point, which is right at the end over here. And that's, now double check and make sure that looks right. Yes, it does look right. Okay, and if that looks, that's important because everything's going to go skew if you don't get that right in the middle of the gas canister hole. Okay, after you've done all that, you can hit post-process. Now you'll be asked, where do you want to save this? I suggest you save it exactly where you got your file from. Now in this case I'm in the wrong folder, so double check because often you'll lose it. It'll default to the previous saved position. I'm going to Gira F1 where I've kept all these, and this is Team Aphelion, and I'm going to save it here. And it's going to save it as an FNC file, Fanuc Miller or something, whatever it is called, file. So save. Now that is fine and everything is good, and we could machine the car as it stands, barring a couple of very important selections. We've only created a machining on one face, and this particular car has to have work done on underneath it, and it also has to machine on the other side. So now we have to go and open up a Notepad. So if you can find Microsoft Notepad somewhere, you just click on your accessories over there and find Notepad. I think you'll find it here somewhere, under N, somewhere around here. I've got it open, so I won't waste your time by looking. You know, you'll find Notepad, LMN, somewhere over. You'll find a Notepad sitting around. Escape out of that. I've got it open over here. Here's Notepad. There it is. And I've opened up this FNC file in Notepad, and this is what I'm looking at. Now, notice that what you're looking at here is a whole lot of G's. That's why they're called G codes. The locations are given by an X, Y, and a Z coordinate, and there's also information about the speed at which the machine head travels, the speed of rotation. There's a whole lot of stuff in here. You need to scroll down from the top all the way down until you find this section here where it says M03 S23000. That's the instruction for the machine spindle to begin to spin at 23,000 RPM and ready for work. Now underneath that, you won't see this, what I'm highlighting now. Underneath your normal file, you would see M03, S23000, and they go onto here, G00, go to X at 124.365 millimeters, and then go down Y negative, so forth, so forth. You have to add in all this code that I've highlighted over here. So this section over here, you've got to add in. And the first thing is the /M71. That is a mirror feature which says very quickly and easily for you to be able to machine the opposite side exactly the way you've machined the first side of your project. So it basically replicates what we've done over here in QuickcamPro on the opposite side using a small feature in the milling software called skip block. So make sure you /M71. Then you type in G0, leave a space, and then X, capital X, and then remember those dimensions we wrote down, the distances that the car was, all the different from the axle, the rear axle to the rear of the block, and the front axle to the rear of the block, and the perpendicular distance from the gas canister, center of the gas canister housing to the axle height. Remember all that? Okay. After the X, write down the distance from the rear axle to the rear of the block, and that was 45 millimeters if you recall on my previous tutorial. You can put the point there, or you can just leave it without the dot, then a space, then Y, type in Y, and then negative the distance, the perpendicular distance between the center line that goes through the gas canister housing and the axle height. Remember we measured that at 19.5? So it's negative 19.5. Space, then type in Z 33.5. That's going to tell an instruction to move the tool. Just type that. Then type in G1, space, then Z, negative 3, then a space, F2000. Then Z underneath that, 35, space, F4000. Then G0, space. Now, at this point, you're going to type in the distance after that X from your front axle to the rear of the car, and we wrote that down as 130 millimeters. So it's X 130. Now if your car was 130 or 122.3, you'd write 122.3, but mine happens to be 130. Underneath that, type in G1, space Z minus 3, space F2000. Underneath that, type Z35, space F4000. Get all this right, make sure it is precise and absolutely correct, and then you can just copy and paste this particular module of code into your next file if you want to make one, and all you need to do is change the various different lengths of distances from canister housing to axles, and from front axle and rear axle to the rear of the block. Okay, does that make sense? So this bit of code tells the machine to drill the axle holes. It's not normally there. Alright, once that's done, you can save that. So File, Save. And you have completed your machining for machining these two side faces of your car. Now, if you wanted to do I'll do another tutorial to show you how to do the other faces, so the underneath of the car or machining from on top. But for the moment, well done. If you get this far, you've succeeded in creating the machine code files, and you'll notice here that there's a lot of them. Alright, there's going to be probably, maybe in the order of 20,000 of these codes, yeah? And right at the end, they'll stop, and each one of them is basically a location telling the tooltip to move to this three-dimensional Cartesian coordinate. And there's just zillions of them, okay? And that machines your car.